um quiz be like in questions?
Um, so I think, for example, there might be a question like, here's a line. Sorry, 1 second. Here's a line, here's a point, find the distance between the point, the shortest distance between the point and the line. That might be a question. Or, so yeah, stuff like that. So I don't know how long they are. They're not necessarily short. They're not extremely long. There might be like a few parts to each question. And they're going to be 5 questions, and you're going to have 60 minutes to do them.
Okay.
If you guys think that 60 minutes is too short, I can do longer. We can do it for like 2 hours or 3. But the structure, I think, should be like 5 questions with a couple different parts to them. So would you guys prefer if the time limit was longer?
I think it might I might prefer it longer, at least for the first one, just to see how long it might take me.
Oh,
I
yeah,
agree.
fine.
Yeah.
Sure. Yeah. Yeah.
And Professor, could you please do a review for the quiz?
Well, I'd rather not do a review for the quiz. I'd rather keep moving on with the material. If there are any specific questions that you want to go over, then email me and we can go over those questions. But yeah. Listen, study like projections and the component for projections. So being able to do that, cross products, areas, parallelograms. So yeah, you can also look at the videos that we had, although I didn't post the videos from last class yet, but you also have the textbook, so.
Is the question gonna be the same with the examples we go over in class?
Like the whole, yeah, it's going to be similar to the learning curve problems, but some of the quiz questions might like require the steps that you did in the learning curve problems. It might require two or three of those steps at once or something like that. I don't know. But some of the questions can be easy. They can be like, find the projection of one vector onto another vector, which you should be able to do. Or being able to tell if 2 vectors are orthogonal to each other, or parallel to each other, or not parallel or orthogonal. So all those type of questions can come up, and you should be able to tell using the dot product and the cross product how that goes. I might ask a torque question because we looked at the torque question. And okay, fine. So here I can go through the material, I guess, from the beginning and see what kind of questions can appear. So let's do that.
I had a quick question. When will the quiz what time will the quiz come up, and what time do we have until to start the quiz for tomorrow?
Yeah, so it's going to come up hopefully fairly early in the day, and you're going to have the entire day to do it. But you would have, yeah, like 3 hours, I guess. And If it's gonna be 3 hours, I'm gonna do 6 questions. So there are gonna be 6 questions, and yeah, and then just post the answers on Canvas, and that'll be that. So let's see. So I'm going to start, I guess, with the line part, because the earlier sections are fairly basic, and obviously, like, there might be questions that involve, like, 1 second. There might be questions that involve finding what PQ is or stuff like that, and that can definitely be part of a problem, but it's probably not going to be an entire. So, okay, so let's do that. You can have questions involving, let's see, so lines and curves. So definitely there's probably going to be a question which involves you finding a line like this, or using a line like this, or maybe, so for example, if let's say you have a line and you have a point, so here's your point P, and here's your line R of t is equal to P0 plus TV, then you can be asked, find the distance from this point to the line. And the way to do this is to arbitrarily pick a point on the line. So call this point Q. And you can find Q by setting t is equal to 0, for example. So that's when you can find your Q. So then your P0 is going to be your Q. So then P0 is equal to Q. And then you find, so let me go here. So here's your point P, and here's your line, and this is the line R of t is equal to P0 plus TV. So what you end up doing is you find the point Q on the line, and let's say that Q is going to be when t is equal to 0. So that's going to be t is equal to 0. So then Q is going to be equal to P0. And then you find the vector from P to Q. So then that's this vector over here. And again, we're looking for the distance from P to the shortest distance from P to the line. So now you do this. And now the way to finish this problem, well, there are a few different things that you can do, but one of them is that this V over here, this is a vector. So you can use these two vectors over here. This is the vector PQ and the vector V. You can use them to find the angle, this angle over here with the dot product. And then you can use this angle and the magnitude of PQ to find the height over here with the formula that y, or the height or whatever, is going to be equal to the magnitude of PQ times sine of this angle over here. So that's one way you can finish this problem. The second way you can finish this problem is with the cross product, because that, well, again, the cross product does what sine does. So you can actually use the cross product. So this is the type of problem that can appear. And with regard to lines, for example, And another type of problem is whether two lines are parallel. And we have seen those problems. So let me, 1 second. It's not, okay. So, yeah, so types of lines. So we've seen questions about whether lines are parallel, whether lines go through a point, whether two lines intersect. That was one of the questions that we did. So yeah, intersection of two lines. So for that, you set the two lines to be equal to each other, like we saw. So these are definitely the type of problems that can appear. And the main stuff that you need to know from this section is the equation for the line. So definitely know the equation for the line and how to read parts of it, how to read this part and how to read that part. Because otherwise you won't be able to solve a lot of problems with regard to lines. So let's go through, let's look through some of these questions quickly. So you see if so these types of questions are actually fairly simple. I don't know if I would ask one of them. Let me continue looking. So you can actually look over these questions and make sure that you know how to do them, because so far they have been fairly basic. So you should definitely be able to know how to at least construct these problems. Like definitely know how to do the unit vector in the direction of u, or the unit vector in the direction opposite. So definitely those type of stuff should be fairly basic. If you have any questions about that, let me know. And then definitely for the types of questions for lines, you should be able to create a line that passes through a point with a direction v. So you just use the equation that we saw. Are there any questions about these problems in the book? These are the types of problems that you should know how to do fairly like if you have 2 points and I ask you to find the line going between the 2 points, you should be able to do that. You can use one of those points for P0 and then you create the vector PQ. Yeah?
I had a question about the quiz. Will we be doing multiple choice, or will we like use
No,
our work on a paper and scan it in?
you're gonna have to write the answers on a piece of paper and take a picture of it and upload it.
Okay.
Okay. Yeah, but so far is this doable? Hello?
Yeah,
Oh,
Yeah.
yeah.
Okay.
Professor, you said we can use cross product to find the distance between the point and the line. Can you just go over like quickly how you do that?
Yeah, so um so we're trying to find h, and h is PQ sine of theta. And sometimes you would want to find theta, and obviously you can find theta with the equation theta is equal to cosine inverse of v dotted with w over the magnitude of v times the magnitude of w. And then you can use this, but you can also say that you can skip this part and you can say, well, that our cross product kind of does what sine does. So this is also going to be equal to the magnitude of PQ times the magnitude of V over the magnitude of v times sine of theta, which is equal to the magnitude of PQ cross V over the magnitude of V, which means that your height is this, and so you can use this to find your height. Yeah?
Okay, thank you.
Okay. Okay, so definitely any one of these questions so far that I've seen can appear on the quiz. Show the two things define the same line. So definitely that type of stuff can definitely appear on the quiz. Determine whether two lines intersect, and if they do, find where they intersect. So again, those type of questions, so any one of these type of questions can also appear. I don't think I would do anything with laser beams. So like just math questions, nothing too exciting. Okay. And then dot products. So definitely know how to take a dot product, and then know that the dot product is connected to cosine. So if you need to use it in a problem, it will have something to do with projections or something to do with finding angles. Definitely know how to use this formula, how to find angles. We just saw a problem where finding an angle would be useful. So yeah, definitely, again, know how to find an angle. Know how to use the dot product to figure out whether two vectors are perpendicular. So that's pretty important and might appear. Yeah, so once again, projections. So pretty important topic in the topic of dot products. So know the formulas for projections. And I would even say at this point, we've spoken enough about it that you should know the orthogonal component of the U vector. So you should know its projection, you should know its orthogonal component. You should know how U gets decomposed into two. It's fairly simple. It's the tail rule. You just put the tail of one onto the other, the projection onto the orthogonal, and you get back U. So in fact, this could also be used to find, if this is your V and this is your U, this could also be used to find the distance between between your U and your line. So that's another way to solve the problem. So yeah, know how to decompose a vector. I would not ask this type of physics question. I wouldn't really ask any thing like that. I mean, it's important, but not necessarily in this class. It is very nice to be able to like decompose the forces, gravitational forces, and that's basically what they're doing here. But I'm not going to ask a question like that. So just to let you know. And yeah, so definitely know this formula. Know how to use it, know how to think about it, know how to find the angle between two vectors, know how to figure out whether they're orthogonal, know how to decompose them, know how to find the projection, know how to find the component of the projection of one vector onto the other, and know how to find the projection itself. So this is the projection itself. So any questions about this?
So for formulas in general, should we have it memorized?
Yeah,
Okay.
yeah. There aren't that many. I don't think there are that many formulas. And if you're having a problem, you should be able to derive them. Yeah, generally in a normal class, you would just have them memorized. So I would recommend that you memorize them. But anyway, so for any of these, like compute the dot product, obviously these are important to know. I'm not going to ask a question where you just have to compute the dot product. That would be like, oh, find this projection, because you would have to compute the dot product along the way, but also show that you can compute the magnitude and that you know how to use them. And so, but definitely know how to compute the dot product. Finding cosine of the angle between vectors, important. I generally would ask you for the angle itself if I was gonna do a question involving that. So yeah, find the angle between vectors. That might appear actually, because that does require computing the dot product, dividing by two angles, knowing the formula. So yeah. Um, so a lot of these type of questions might appear, they might not. My guess is they won't. The later ones, let me see. Yeah, like find an angle between them. If this is equal to that, is you need to compute it. They get divided, obviously, and so I don't think I would necessarily ask questions like that. If I do, I don't think it's very hard to be able to solve them. Finding the decomposition, like I said, that I might ask. So here's a vector, decompose it into its orthogonal part and its projected part. Definitely might ask that type of question. Okay. Okay, so let's continue. Yeah. So these type of questions, anything to do with proofs, I'm not gonna have anything like that. And then cross product, I might ask a question with torque. So that should definitely be studied. And not going to just ask a question with the torque determinants directly. But definitely the cross product, you should know how to compute the cross product. So you should know this formula. There isn't anything else you can do, honestly. And you should know this formula, that the magnitude of V cross W is equal to the magnitude of both of them times sine. You can also use that to find an angle, by the way. So definitely know why this is true. It explains what cross products are doing, that they're orthogonal to V and W. If two vectors are parallel, you can use the cross product to figure out whether they're parallel. You just do V cross W, and if it's equal to 0, you know that they're parallel. So definitely know that that's an option if you want to solve a problem. There might be easier ways of solving the problem, might be harder ways, but it is a solution. Know how to do a problem like this. I said I would not do a physics problem, but I would do one physics problem. If a physics problem does appear, it would just be this problem: how to find torque. So definitely know how to do that, and it's fairly simple. Just yeah, look at your R, your distance from where the force is being applied, and the force that's being applied. And then definitely know how to find areas using the cross product. So yeah, the cross product gets you the height. It gets you Y, so it can be used to find areas for parallelograms. So we spoke about why this formula is true. Definitely know how to use it to find the area of parallelogram created by V and W. That might appear, or the triangle. So that might appear. Definitely know how to do these problems. Know what the the scalar triple product is. You don't have to know anything about it other than it can be used to find the area of a parallelepiped. So you actually don't have to remember it, and you can just do what we said, that it's equal to the determinant of those three vectors for the parallelepiped. So if you want, you can use this formula to find the area of your parallelepiped. And if you want, you can use the scalar triple product. Either one of them work, but that's what you need it for. You need it for the area of a parallelepiped, and that's basically it. And so yeah, I know how to do that. And let's see what else. So at this point, we are at some proofs. Yeah, so we didn't finish. I don't believe we let me see. I don't believe we finished. Yeah, sorry. We came up to here, I think, in R2. So we didn't finish all of this. So I'm going to finish it today, and this will also be relevant for the quiz. And yeah, that was basically the review. So was that helpful? Any questions about that? Hello?
I thought that was good.
Yeah.
Oh yeah. So now they're telling us that in R2 you can also find the area made by two. So if, sorry, this is x, y. Here's a vector v. Here's a vector u. And now I'm in R2, so my v is, let's say, equal to v1, v2, and my u is equal to u1, u2. And now let's say I want to find the area that of the parallelogram that's created out of these two vectors. So let's say I move my v, so here's my v, and I move my u, so here's my u, and I want to find this area. Well, so because I only have two components, if I wanted to find the cross product, and that's what we need in order to find the area, if you have two vectors in R3, we said that the area of the parallelepiped was the magnitude of V cross W, but this required that they have three components, that V and W require three components. Over here, you only have two. So what they say is, oh, the simple solution is to just add a component. So go to another dimension and say, okay, let's imagine that this is a problem where my V is really V1, V2, and 0, and my U is really U1, U2, and 0. And now if you want to find the area over here, well, that's going to be the magnitude of V cross U, which is going to be equal to I, J, K, and then you're going to have V1, V2, 0, U1, U2, 0. And then this is going to be equal, and then I times the determinant of this, well, that's 0. This times this is 0. This minus this is 0. J times, and then you're going to add this times this is 0. This times that is 0. And then K, and you get rid of that, and then you have this times this, which is V1 times U2 minus, and then this times this, which is U1 minus V2. Sorry, times V2. So And this is just the determinant of these two vectors, right? If I look just at the determinant, so this is equal just to the determinant of v1, v2, u1, u2. So it's just another formula or another way of finding the area of these two of this parallelogram, and but it really uses this formula. So honestly, you can just remember this formula for the area of the parallelogram, and you don't really have to remember this. But anyway, yeah, so that's what they're saying over here in R2. When you only have two components, you can add a 0 to your component, and then you take the cross product, and you get, this is the only thing that really matters. And when you take the magnitude, you get that the area of this thing is going to be equal to the determinant of these two vectors, like we saw. Any questions about this? Okay, so now they ask us to compute the area of the parallelogram in figure 14. So that's this figure over here. So we have these two vectors. So like we just said, we can just look at the determinant of the vector 1, 4, 3, 2. And that's going to be equal to 2 minus 12, which is going to be equal to negative 10. But we take the magnitude of this because that the area is always positive. So that's equal to 10. So yeah, that's over there. And then they now go and they derive some of the properties that we talked about regarding cross products. So the most important formula, again, that we talked about is this formula over here. And the main point for how to derive it is that, okay, up here they showed this formula, they derived this formula. I don't want to go into how they did it. And then they use the fact that the dot product is connected to cosine to jump from here to here. And they just replace the dot product with the magnitude of v squared times the magnitude of w squared times cosine of the angle squared. So just plugged it in. And then from here to here, well, that's just taking out this part, the magnitude of v squared times the magnitude of w squared from both of these. So it's just taking it out here. And then over here, from here to here, it's just a trigonometric identity, the main trigonometric identity for sine of cos and cosine. And then we get this in the end. So we get this is equal to this. And so that's how we get this formula. So in fact, this formula actually comes from the formula that we spoke about with the dot product, that v dotted with w is equal to the magnitude of v squared times the magnitude of w squared times cosine of the angle between things. And like I said, this formula comes from the law of cosine. So all these formulas basically go back to the law of cosine, really. And okay, so that's the end for this section with the cross product. And like I said, all this stuff you should know for the quiz. So again, know what the determinant is for 2 by 2 matrix. I'm not going to necessarily ask you a question directly about determinants, but obviously you need to know what they are. They're very important for cross products. Know how to take the cross product. Know that it's orthogonal to v and to w. It's just very important to being able to do a lot of problems. For example, I can ask you, I can give you two vectors, and I can tell you, oh, find the equation of a line that goes through some point P0 and that is orthogonal to both of these lines. So to both of these vectors, to both the vector v and to the vector u. So find the line that's orthogonal to both of these vectors and goes to the point P0. And well, what you have to do is you have to take the vector v cross u to be your vector in your line. So then your line is going to be r of t, is equal to P0 plus TV cross U. So definitely know how to use the cross product in order to be able to solve those type of problems. So yeah, so know that it's orthogonal to both V and U. Know this formula. Know this formula and why it's true. Know why this is true and how to use it. That if two vectors are parallel, then their cross product is 0. Yeah, and then know the trailer. Again, know the area of the parallelogram. Sorry, yeah, the area of the triangle. The scalar triple product and how it's kind of connected to the determinant. So either remember it as a determinant, I guess, or as this, but know how the parallelepiped, its volume is given by this formula. So those are the main points from this section. So over here, these type of questions, basically being able to use the main formula is very important, this formula, and that's what this question is trying to see, if you know how to use this formula. Well, obviously, it is important to know how to use this formula. So any question like this can definitely appear. It might not. It might be a little too simple, but know how to do it at least. So a question like this you should also be able to do. These type of questions I would not ask. So being able to find what the cross product would without using the actual formula of the cross product, I won't ask you unless it's like something like this with I's and J's, something very easy. Otherwise, oh, or something like this. This is also very easy. It's just going to be 0. And this one, okay, that's also easy. So I would ask you for those questions. If it's some weird geometric thing, I won't ask you. So it has to be something simple, geometrically speaking, if I'm gonna ask it. Yeah. Yeah, but then being able to find determinants, you should be able to do that, but I might not necessarily ask you, but definitely being able to compute the cross product, you should be able to do that. I might not necessarily ask you directly to compute a cross product, but you will have to compute one during the quiz, so definitely know how to do that. So the physics questions that you see over here, I am not gonna ask to know what this is again, but again, it will only appear if I'm asking about the volume of a parallelepiped. Otherwise, you won't need to do anything related to that. What else? And then all this type of stuff. Sketch parallelogram, compute the area, find the area of a parallelogram, sketch a triangle, find the area, find the cross product. All of these type of questions I definitely might ask. So yeah, definitely might ask those type of questions. What else? I think that's basically it. I won't ask any proofs. Yeah, so that's any questions about that?
The quiz is Tuesday.
No, the quiz is tomorrow.
Okay.
Yeah, so I'm gonna just post it on Canvas sometime tomorrow, hopefully in the morning. And yeah, you'll have 3 hours, I guess, to do it. It should be like 5 or 6 problems. Some of them might have like multiple parts, like in order to find the the angle between two vectors, you have to find the dot product and their magnitudes and put them in cosine inverse. So definitely a question like that might appear, but none of these questions are very difficult. So it won't be anything too difficult, I don't think. Okay.
When we write out our work, can it be on a tablet and stylus, or does it have to be pen and paper?
Can you upload what you're doing as a PDF or like download it as a PDF and then?
Yeah, I can do that either way. I was just wondering if you had like any like limitations
Oh yeah,
or restrictions.
no, it doesn't matter. Stylus is fine as long as you can get a way to upload it like normally, because it's just gonna be like upload. You just upload the PDF or something. So yeah. So yeah, definitely that would work for sure. Any other questions? Okay, so let's continue with what a plane is. So the formula for a plane that we're going to see a bunch of times is the formula ax plus by plus cz is equal to d. This is the formula for a plane. It kind of comes from a line, but it has a few extra parts, and so that's what we're gonna look at right now. So first, in order to know what's important about this, the most important part about this formula is the x component, the y component, and the z component, and you can put it in a vector, and we call it the normal vector to the plane. So it's the vector n, and it's the vector a, b, c. And we will use this vector a lot. And it's actually, we will see in a second, if my plane, if this is my plane, okay. If this is my plane, then the normal vector is orthogonal to the plane. So it's pointing out of the plane. And it is fairly important to know what the orthogonal vector of a plane is. It basically defines the entire plane. And so yeah, that's going to be this vector over here. And then this d over here, so you see there are many vectors like this. There's this vector, there's a vector a bit higher. It's a vector that starts over here, and it's also parallel to that vector. And then there's this vector. So all the planes with these normal vectors, there are a bunch of them. There this one, then there's a one over here, one over here. So this this number tells you where this plane lies, how low it goes, or how high it goes. Basically, I mean, the plane might go to infinity if you walk along it in the x, y, or z. Sorry, in the x or y direction. But that's not the point. The d just pushes the plane up or down, and those are the four main parts of the plane. And so let's look at what they have to say. So the main reason why this formula, so here's the formula that we just talked about. And again, it's ax plus by plus cz is equal to d. And the main reason, well, if we wanted to figure out the formula for a plane by ourselves, then we would have to go, then something that we can try is we can try to do something like this. Let's talk about a normal vector. So here's my normal vector. It's the vector a, b, c. So here, my normal vector. And I want to find all the vectors that are orthogonal to this normal vector. And that's going to define my plane. So I want to find all the vectors such that when I dot them with my normal vector, I get 0. And then if I can get a list of these vectors, I will have my plane. And these vectors, so let's say this point over here, let's say this point is the point x0, y0, and z0. Then the points orthogonal to my normal vector, or any point lying on the plane, let's say a point from x0, y0, 0, to a point over here, lying on my plane, which would be the point x, y, z. This is a point lying in my plane. So the points x, y, and z, they're the points lying in my plane. So any one of these vectors, well, it would have the form, one second, x minus x0, y minus y0, and z minus z0. Right? So let me just erase part of this, and I'm going to rewrite the formula that we just wrote over here. So we wrote that the normal vector dotted with the vector x minus x0, y minus y0, z minus z0 is equal to 0. And all the x, y's, and z's, so all the x, y's, and z's that satisfy this formula, which means they satisfy that looking from x0, looking at the vector from x0 to them, so from x0 to that point, looking at that vector and dotting that with n would give you the 0. So all such x, y's, and z's, they define our plane. They define our plane. Okay, so now let's rewrite this and to see what we get. So let's try to rewrite this. So far, is this understood?
Yeah.
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 Okay, so let me just rewrite it over here. So that tells me that A, B, C dotted with x minus x0, y minus y0, z minus z0 is equal to 0, which tells me that A times x minus x0 plus b times y minus y0 plus c times z minus z0 is equal to 0. And this tells me that ax minus ax0 plus by minus by0 plus cz minus cz0 is equal to 0. And this tells me that ax plus by plus cz is equal to ax0 plus by0 plus cz0, which I can call d, which means that ax plus by plus cz is equal to d. And so that's how we get that the equation of our line is this formula over here. Now, if I have a normal vector and a point, I can find the plane that goes through that point with that normal vector fairly easily. So is this good? Can I erase this and then I'll try to show a problem like that?
Yeah, go ahead.
So actually, let's finish over here, and I'll start again next time with what a plane is, and we're gonna do a problem on that. Okay. So, are there any questions? Okay, great.
Nope.
Yeah.
I was just saying no.
Yeah. So, have a nice weekend.